everyone. Welcome to your play posit for the day. We're going to be covering Unit 4. So we are out of Unit 3 and we're into Unit 4 now in the play posits in our live classes. So it's kind of exciting. We're a teensy bit ahead in our live class of your online curriculum. So I like to either be on pace with you or a little bit ahead. So that way when you do get to that lesson, you'll be good to go. So have your notes ready. Open your OMHS Play Posit graded assignment and let's go. Just another quick reminder that our end date for this first quarter is this Friday. Remember, after November 6th, you guys will no longer be able to access those graded assignments. So please make sure you're completing anything that's missing, anything with a 0, and then review and retake any low graded assignments. And please reach out if you need anything at all. So we're going to finish our notes from last class, those breakout room problems, and then we're going to start Unit 4. That's going to get us to some three-dimensional shapes coming up. Not today, but we're working towards that. All right, so you guys did an amazing job in the breakout rooms last class. I just wanted to go through these to make sure that we were all on the same page so you can grab your notes and make sure that you have these answers. So remember, we talked about these being a little bit differently written than the others. They have some statements over here that are marked on the picture. So if they're already marked, that means it's given to you. So the fact that LM is congruent to LO is given in the picture. So that's the reason. Sometimes we see the givens written up here as statements. That's another way you can see that. So same thing for number 2, right? That's our second pair of congruent sides that is also given to us in the picture. And then it tells us that LN is congruent to LN. So that is not marked in the picture. So that is something we do need to come up with a reason for. I'm going to mark it. And the reason we're able to mark this, remember when two things are squished together and they share a side, that is that reflexive side. If you want to get really specific, you can say the reflexive side congruence postulate. That is fine. But that just means that when two triangles or two shapes share that side, then it's the same. If we were to separate these triangles, each triangle would have LN as part of its shape. There we go. I just separated them apart so you can see that those two sides are equal. So then we have that the triangles themselves are congruent, and we're allowed to say that the entire triangle is congruent by those triangle congruence postulates. So sometimes it helps to label what you have, and then the postulate will like jump out at you. So we have side lengths marked. So this is the side, side, side postulate. There we go. Let's try the next one. So again, this is given to us in the markings on the picture, GI and KI. Same thing with number 2. So then it says GIH. GIH. That angle is congruent to KIH, the angle right across from it. So this is another very special type of marking we're allowed to do. Those are vertical angles. They are right across from each other and they are always equal. Vertical angle congruence postulate if you want. Say vertical angle is congruent. And lastly, they want to know which postulate makes the triangles congruent. So we have a side, an angle, and a side. Side, angle, side. This is the side, angle, side postulate. Don't forget, you can pause this recording at any time. Number 3. This is also given in the picture. Number 2 is given to us the reason, but they want to say which angle is congruent with OLN. So let's just map that out. OLN has the markings with the 2 tick marks. So the other angle that has 2 tick marks is this one here. So there's a few ways we can label that. We can label that MNL. MNL. Or if you wanted to, you could say LNM. I'm sorry. Why did I say L? Let me erase this. Did you guys see that? MNL. MNL. There we go. Or you could say LN. NM. As long as N is the vertex of that angle, that's all that matters. That's the one that's labeled with those two curve marks, which matches OLN. All right. The reason number 3 is the reflexive property. So this is another example of the reflexive property where those triangles are squished together. So that's the LN side length is congruent to LN. LN is congruent to LN. All right, so what do we have marked? We have an angle, a side, and an angle. That is the angle, side, angle postulate. Here's our next one. Angle Y and angle C. Those are both marked in the diagram. So that is given to us. And then number 2 says, what else is given? What else is given in the picture? Oh, the markings on the side length. So YA is congruent to AC. You could write those letters in any order you wanted to, right? YA or AY, AC or CA, up to you. Then number 3 tells us vertical angles. So which angles in this picture are vertical? These guys. So we have angle Z, AY is congruent to angle, these are really small spaces, sorry guys, BAC. Here we go. Now let's see what markings we have. We have angle, side, angle. Angle, side, angle, congruence postulate. Shorthand. All right, number 8. I'm sorry, slide number 8. I think this is number 5. So the given for angle T is congruent to what? Well, angle T has the 1 tick mark, so that is congruent to the other 1 tick mark. And we'll follow suit. Since they use one letter, we'll use one letter for angle V. The other thing that's given, excuse me, are the 2 tick mark angles. Now this is a little tricky because we can't just use X and V, right? Because X, in this case, we wouldn't really be able to tell which angle we're talking about, right? We were allowed to use just the letters up here because it's just one angle. Down here, we've got 2 going on. So we need to pick out the exact one with the 2 tick marks. That's going to be VXW. VXW. VXW is this first one, and the second one is here. XWT. XWT. Tricky, tricky. All right, number 3 is the reflexive property. So remember, reflexive property is where they share a side. So it's not going to always be where the shapes are stuck together necessarily. I mean, these are still stuck together. But they do share a side, right? They share that XW. So if you were to separate these triangles out, you would see the overlap there at XW. T and V. So XW is that reflexive side, the side that the triangles share. So because they share it, it's going to be the same in each of them. Let me mark the other angle to help us. There we go. So now what do we have marked? We have angle, angle, side. Angle, angle, side. It's the angle, angle, side postulate. This one was hard, you guys. What did you think? I bet you, I don't know. I'd like to hear. All right, so that wraps up our proofs unit. And if you guys need any help at all, please do not hesitate to reach out. I know that you're coming up on your unit assessment for that. So now let's move into unit 4. We're going to talk about perimeter and area. Now I know that we've been doing perimeter and area probably what feels like forever, right? Like my daughter in kindergarten is learning about perimeter. So we're going to talk about it generally, and then it's going to get more complicated, obviously, into our geometry topics. Remember what perimeter is? Perimeter is the length or the measure all the way around the outside edge of something. All the way around the outside edge. So depending on the shape, will depend on how we find the perimeter, but really the technique is the same. You just add them all up. All we do is we add them all up, add all the lengths up. Area, I think of coverage. So you think of like a wall. How much paint do you need to cover the area? Or you think of maybe a tablecloth. What size tablecloth are we going to need to cover the entire table? Or maybe you think of, I'm looking around my house, carpet. How much carpet do you need to cover the entire floor? So you think of coverage. Area is always squared, like feet squared, meters squared, and perimeter is not. It's just whatever the units are. So that's a little quick review on the difference between perimeter versus area. So here's some good news. This is not your first high school class that you guys have taken, right? Everybody took Algebra 1. And you guys know that you guys get a formula sheet on the SOL. So here's a snip of just the top of your formula sheet. And you'll see you get a lot of the formulas that you're going to be asked to use. Triangle, area of a triangle, rectangle, and so on. So we're going to be able to use the formula sheet anytime in class and also on your SOL and on any tests or anything. You guys, this is a resource you're allowed to use in your class on anything. You can find this formula sheet in our OMHS folder. Let me show you where it is. Let's see. All right, I'm going to show you where to find your formula sheet, and I would recommend go ahead and printing it out and have it near your workstation so you can just grab it whenever you need it. I'll just log in real quick. Must have logged me out. So when you go to your geometry course page, like I just did, and we go to content up at the top here, it's loading. All right, we're going to scroll along the left-hand side, and you're going to see course materials. And this is where it should be for you guys. So I'm going to put it right here. Your SOL formula sheet is going to be right here under course materials. And you can click it, and you can print it, you can save it, all of that. So let's talk about composite figures first. That means that it's a composition of many shapes. So when we look at this shape, I mostly just see like potentially squares maybe and rectangles. That's pretty much it, right? Nothing crazy like triangles or parallelograms or trapezoids. So we're going to talk about squares. Remember perimeter and rectangles. Perimeter is the length all the way around. So we have to use some clues in the picture to help us out. We know about these markings, right? Look, the 1 tick mark matches with this tick mark. So if this is 10, this is also 10. 2 tick marks is 20 inches. So all these guys are 20 inches. There we go. Do we have enough information to just go ahead and add it all up? Yeah, look, we know all the side lengths now. So the perimeter, you just add it all up. 60 plus 1, 2, 3, 4, 5. There's 5 20s. I'm going to multiply that by 5. And 2 10s, right? Let's make sure I got that right. 1, 2, 3, 4, 5, and 2 10s. Yep, so we're going to have 60 plus 100 plus 20. 180, right? 180 inches is the perimeter. Maybe this is your yard and you're trying to figure out how many inches, or feet rather, probably, of fencing to purchase to fence in your yard. So there's definitely real world application here. So the area of the figure, maybe you're trying to purchase enough sod. Sod is like not fake grass, it's real grass, but it's like rolled up grass. It's crazy. I don't know if you guys have ever seen sod. I'll try to show you a picture in our live class. And you want to cover the entire ground with sod, or even I had a neighbor who filled their backyard with turf. So how much turf do they need to purchase to cover the whole area of the backyard? So if you want to take a glance at your formula sheet, you see the area of a rectangle and also a square is length times width. So we need to probably break this up into a few different sections, right? We're going to have I see like a few shapes here. Do you guys see that? This is why it's composite, because I kind of see three sort of separate shapes poking out at me. All right, so let's find the area of each piece of this composite figure. So remember, area of a rectangle or a square is length times width. So we could find the area of this first square here. 20 times 20 would be the area of that. So that's 400. Right? And then this one is also 20 by 20. And lastly, this is where it gets a little tricky. We know the length of this little rectangle, but do we know the width? And not right off the bat, right? It's not labeled, but could you figure it out? We know the whole side length is 20, and this little piece is 10. So these must add up to give you 20. So that is 10. Now we wouldn't want to just assume it's 10 because it doesn't have the tick mark, but we use the fact that the entire length was 20 and this piece was 10, so it happened to also be 10. So this would be 10 times 20 for that area there, which is 200. Now we can add them all up. Let's see, 4 plus 4 plus 2 is 10. We have all those zeros, right? So we get 1,000 inches squared. Remember, the area is always squared. And the reason for that, I'll show you here on this square, we had 20 inches times 20 inches. That's how we got 400 inches squared. There are 2 inches here, and when you multiply, if you remember from Algebra 1, remember when we do x times x, we get x squared, because there's 2 of them. Here there are 2 of those inches, so we get inches squared. That's why area is always squared. And that's it. So we're going to see a few different type of composite figures this year. This is just one of them. We'll do some more next class. Let's try this example. The perimeter of a rectangle is 20 centimeters. P is 20. The width is 4. What is the area? So remember, area of a rectangle is length times width. So we use what we have. We're given the perimeter and the width, but we need to find the area. So let's put the perimeter formula here. The perimeter formula from your formula sheet says it's 2L plus 2W. So remember we said perimeter, you just add them all up. This is kind of like a shorthand, length, width, length, width. See how there's 2 lengths and 2 W's? That's where they got these 2's from. So let's plug in what we know. We know P is 20 and we know W is 4. Look, now there's just one variable L. Let's solve for L. Plus 8. So we would subtract the 8 from both sides, right? And I inevitably always run out of room. You guys know me. So we get 12 equals 2L. We'll divide both sides by 2. L equals 6. So now we have the length and we have the width, and we can use that over here in the area formula. Oops. Width is 4. So the area is 24, right? 24 centimeters squared. So first we had to use what they gave us with the perimeter and the width to solve for W. and then take W or to solve for L, and then take L and W and plug it into the equation. All right, let's talk about the height of a triangle. So we all know what a triangle is, and I just wanted to show you 3 different ways that you can see the height drawn. Here's the first one, very traditional. There's the height. The height is from the base to the top of the triangle. Here's a second way you can see it written, sort of dropped straight down from the height of the triangle to the base. My computer's gonna die. Let me get my cord. I got my plug. All right, and then another way you can see the height drawn is here in example 3. This has got to be probably the most strangest. So the triangle itself is this one. So the tip of that triangle is up here, so they're going to drop the height down and go to the base. So IJ is that height. You can see that they all form a right angle with the base, or with the ground, if you will. So they're directly perpendicular. It's going to help us when we get to plugging in the height into our formulas. So find the area. Again, this is on your formula sheet. Area of a triangle is 1/2 times the base times the height. So if you look at this triangle, it's turned a little bit. And that's okay. You can imagine turning it if you want to. The height is drawn from the base to the tip, and you see that right angle there. So this is the height, and then here's the base. Equals. So 1/2 times the base times the height. And I'm just going to grab my calculator. Let's do clear. Okay, 1/2 times 9 times 6.4. I got 28.8 yards squared. Remember, area is always squared. All right, let's try this one. The base is 2, and the height drawn is 3.8. So 1/2 times the base times the height. Remember, you can use your Desmos calculator in this class. You can also use it on the SOL. Don't forget the 1/2 in the formula. That's very easy to do. I got 3.8, and that makes sense, right? Because these would divide out. So you get 3.8 kilometers squared. A lot of these are pretty straightforward. You're kind of just plugging in the information you're given. This one was a little more complicated, right? Because we kind of had to work backwards. Let's try the area of a parallelogram. So in a parallelogram, it's just an example, and I just wanted to show you guys what all the different parts are. The altitude, that's just another name for height, which you can see on the diagram from your formula sheet is written with an H, but sometimes you might see it written as altitude. So I wanted to show you that. And then you have 2 bases. It's funny because you would think this is the base and this is something else, but they call them both bases. So here's the base, and then the side across from it is the opposite base. And in a parallelogram, those are congruent. So you just need 1 base and 1 height. Oh, and you know one thing, you remember the formula for a triangle is 1/2 times base times height? That makes so much sense. If you look at the difference in the formulas, half of this would be a triangle. Oh my gosh. So if you were to take the formula for area of a parallelogram and divide it by 2, you have the area of a triangle. Dividing by 2 is the same as multiplying by half, right? So that's pretty cool to see where that came from. All right, so let's practice. Let's find the area of the parallelogram. So area equals base times height. The base is 91.2 and the height is 7. So we're just going to type this in our calculator. 91.2 times 7. 638.4 feet squared. Oh, do you see that? Look, inches and feet. They are some tricky little people here. All right, erase. Let me show you. This is a really good question for us to go over because there are two different types of units here, right? You do see inches and feet. So if you're going to work with this at all, before we did what we just did rather quickly, we're going to need to convert them into the same type of units. So it's up to you guys if you want to turn 91.2 inches into feet or you want to turn 7 feet into inches. Kind of up to you, however you see it. I'm going to turn the 7 feet into inches because we know there are 12 inches in a foot. So that just seems like the way to go. So I got 84 inches for this side. Okay, now we can plug this into our formula. So be very, very careful with the units that they're given. You would never have that in real life, would you? I mean, if you're measuring something, you're going to be measuring using the same units. So this was really just a case of wanting you to be very cautious and careful and have a really good eye. But we know that's not going to happen in real life, having different units. Although, could it? I'm thinking. 7,660.8. Oh, I just can't think of an example. I'll have to think about that, if that could really happen. I feel like if we're measuring something, we would just use the same units. All right, let's try the second one. So we're going to have area equals the base is 2.5 and the height is 1.8. They're both meters. That's good. We checked that. There's some extra information here that you do not need. So don't worry. You don't necessarily use all the numbers. So we have 2.5 times 1.8. 4.5 meters squared. So hopefully you're seeing that it's mostly just using that formula, mostly. All right, let's talk about a trapezoid. So a trapezoid is very similar to a parallelogram, but the bases are not the same length. So you can see up here in our diagram from the formula sheet, we have the height, but then you have two different bases because they're not the same. Bottom one here is longer and the top one is shorter. So we could label this if we wanted to base 1 and base 2. So this time you're going to add the two bases together first and then multiply that by the height and 1/2. So let's try 1. All right, we got 1/2 times the height is 5. And then add the bases together first, right? Because parentheses first. So 1/2 times 5 times 9. Are they all in the same units? I feel like I have to check that now. Miles, miles, miles. It's good that we need to check that, that we know we need to check that. All right, let me grab my calculator. So 5 times 9 times 1/2. We got 22.5 miles squared. We're talking about area. Oh, look at this one. We have inches and feet. So let's convert the foot to inches. We know there's 12 inches in 1 foot. There we go. Now we can use the formula. So the height is 12. And then we're going to add the bases. There we go. I'm going to add the bases first. And then multiply by 12. And then divide by 2. I got 302.4 inches. So just be careful because sometimes the problems might ask for it in a certain unit. So maybe this question said, express your answer in feet. And so if it said that, just make sure you're converting back to what you need to convert back to, right? Okay. All right, you guys, I will see you on Thursday. Thanks so much for paying attention and just reach out if you have any questions at all.